Well, if we're going to do a phase shift, which shifts the graph left and right, we are also going to do a vertical translation or a vertical shift. Uh, Basically, what's happening here for this scenario, um, imagine I have the sine function, and I'm just going to draw a really simple version of it right here. You can see with the sine function, there's this line that goes down the middle of the graph. Know how many cycles it goes through, and we can think of this as the midline. Now, right now, for all the graphs we've done so far, except for like the elephant one and maybe some word problem ones, the middle is the midline is all just always been the same as the theta axis. So, what changes is if we have our function like y equals, I'll write it below. Um, Y equals the sine of theta plus k. Did we use k already with the? Hold on a second. It seems weird to me that we'd use k. Oh, that was the h before. I called it k. Dang. Let me correct that now. Should have been an h on the inside. And I'll write it in bright green here so it stands out. That should be h. And this should be h. I don't know why I was thinking k there. Probably because I was thinking of vertical shift. But it makes sense. Our pattern has always been horizontal shift has been h, vertical shift has been k. I'm sorry about that. I might go re-record that video, but we'll see. Uh, so you notice here that it's outside of the input of the function, and if that's not clear, you can always add in parentheses around the theta, and that says make sure you take sine of whatever the angle is, get that number, then add k to it at the end. And whatever that value is, that's how far up or down we move the midline. So what I would do if I had to, let's say I had a k value of 2, that would mean the midline, I'll draw this one up, should be up, well, I guess if that's 1, it should be up 2 units, all the way up here. So that's the new midline. And then I would take my graph and shift it up. So that's the idea, is the midline changes from being on the theta axis to moving up some k value. All right. One way that you can find the midline of the function is if you know what the maximum value is, um, and you know the minimum value, you can add them up and divide by 2 and just find the average, and that's going to get you the midline. That'll be more important when we go to the word problems later on. All right. Example 2, graphing vertical translations. All right. So, just like before, we're going to talk about amplitude, period, and vertical shift. Notice this time they don't give us phase shift, but later on we're going to have amplitude, period, phase shift, vertical shift, and anything else that we need to do. We'll just basically get used to listing them all. So amplitude, see, I noticed there's a 1/2 being multiplied by the cosine, so there's my amplitude of 1/2. Period, there's nothing getting multiplied by the theta, so for cosine, the standard period is 360 degrees. And then the vertical shift, this is the one that changes. I notice this time it's k, and it's actually supposed to be k. I didn't miswrite my h. Is -2, which means it's moving down 2. Another way you can think about this is I have an equation for the line, y equals -2. That's my midline. Right? That's the equation of my midline. So, I want to know the midline first. And you can even start graphing from here because we just know the midline. I know I'm going negative, so let's go ahead and go negative here. There's 1, -1, oops, -1, -2, -3, -4. Okay. So if I have a midline at y equals -2, let's go ahead and draw it. That is going to be the center of my cosine. Now, just like before with cosine, we want to find where 1/4 of the period is and 3/4 of the period are, because those are our roots. So 1/4 of 360 is 90. No, yeah, 90. And then 3/4 of my period of 360 is 270. So here's what changes this time. Instead of a phase shift adjusting the input coordinates, or the theta coordinates, what's happening is I'm going to adjust the y coordinates. So before it would be 90, 0, but now I want 90, -2. And before it would be 270, 0, now I want 270, -2. All right. And here's the thing. Before, on a normal cosine, we know that the max was 1. Well, now I just subtract 2 from that and I get -1. So let me draw, I'll draw this one in green. Cosine, I know it starts at the max there, -1. Oh, I forgot to, I'll just do my standard 90, 180, 270, 360, bump, and then, what's that, 540. All right. I'll do my standard period breaks here. There's 90, -90, -180. All right. Back to the graph. I got -1 as my max, and I want it to be the same shape, so I know it's going down, and I know it's going to cross this midline at 90, 1/4 of the period, and then it's going to cross the midline again at 270. Halfway in between that should be going down to the bottom, and if the amplitude is 1, I should be above 1 and below 1 on the graph. Go up, down, down, up, and over here we'll go down, down, back up, and there we have all the dots we need to be able to draw y equals 1/2 cosine theta -2. Now, just like I did before, I'll do it real quick. For cosine, the graph normally looks like this, and if I grab it and I move it down 1, 2 units, it fits right on top. Other than, I'm drawing it by hand, so it's not perfect.